Question 1. We have to find a number of perfect squares or square numbers n between 0 and 400, such as the digit sum of n is also a perfect square. For example, 121 is a perfect square, and it has the property that the sum of its digits is 4, 1 plus 2 plus 1, and 4 is also a perfect square. So to start off, I wrote down all square numbers between 1 and 20, and I went through them all again and ticked them off when all of its digits added up to a perfect square, such as 81 had 8 plus 1, which is 9. My eventual answer that I had got was 12, which takes us to question 2, which is the Fibonacci sequence, which is defined by f of n plus 1 equals f of n plus f of n minus 1. We will let x be the number of values of n between 1 and 12 for which f of n is a triangular number. First, I worked out in the table to my right up to f of 12 for the Fibonacci sequence. Then I had worked out all the triangle numbers up to 144 using the formula of n plus 1 over 2, which got me values such as 1, 3, 6, 10, 15 and so on. And I ticked all the numbers which fitted both categories, and I got an eventual answer of 5, which takes us to question 3, which I shall let 5 be the lowest common multiple of two distinct integers of a and b. And to question 4, I shall take the largest value, the highest common factor of a and b. First I looked at the common factors of 5, which were only 1 and 5. The lowest common multiple between these numbers was also 5, and therefore my answer to take into question 4 was 5. Which takes us to question 4. We will let the radius of both circles be 5. Our answer to question 3. We were asked to calculate each shaded area and then add them together to find the total. The shape on the left, the area of the circle was pi r squared, which was pi times by 5 squared, which gave a total of 25. The area of the square, that the cross section shown above has a length of 10 centimeters, and by using Pythagoras on the triangle I worked out that one of these sides were 5 root 2, which gave the square an area of 50, and therefore a shaded area 25 pi minus 50. Right hand side shape, the square has sides of 10, which is twice the radius, so the area of the square is 10 times 10, which is 100. The area of the circle was once again pi r squared, which gave us 25 pi again. This shaded area on the right hand side was 100 minus 25 pi. Then when we added both of these shaded parts up together, 25 pi's cancelled out and I was left with 100 minus 50, which totaled to 50 centimeters squared.